Namaste, my dear students. I am Kamal Nepal, your compulsory mathematics teacher. Today, I'm going to teach you next chapter. It is compound interest. In this chapter, I want to connect with simple interest also. So I want to do review of this simple interest also. So the containing chapters are uh, concept of simple interest, derivation of simple interest, example of simple interest. Then after I want to present you compound interest. Then after derivation of compound interest, an example, similarly difference between simple interest and compound interest. Now I want to start it from first. It is your simple interest. Uh, Simple interest: when a sum of money is borrowed for a certain time, suppose you can take a time 1 year, the borrower after the completion of time returns back the sum borrowed together with sum. If you suppose your sum is rupees 100, time is 1 year, then after you should return not only 100, you should add extra money also. So this extra sum is charged by a money lender to the borrower and is known as interest. That extra sum is called interest. It is for 1 year and it is for certain rate. The interest charge may be two types. The interest charge always from the initial sum lent is known as simple interest. So it is for sum, time and rate. So don't forget, this is your simple concept of simple interest. Then after, I want to connect it how these terms play a role in your simple interest. So the simple interest, it is I or SI, is calculated by the following formula. SI is equal to P into T into R divided by 100. This is your formula. But P, what is this P? P is sum borrowed or sum lent. How much you lend, how much you borrow. That is your principal. Then T, it is time duration. For how many time you took loan, and R is equal to rate percent per annum. Don't forget, this rate is, if you borrow rupees 100 for 1 year, then if you are going to be pay rupees 5 extra, that rupees 5 is 5%. This percent is always calculated in terms of rupees 100 and in terms of 1 year. So that 5% is a rate. It is for rupees 100 and for 1 year. Don't forget, it is the definition of rate. Now I want to derive the simple interest. How can you get this formula? For this one, I want to use here a unitary method. Now look here. The interest on rupees 100 for 1 year is rupees R. The interest on rupees 1 for 1 year is rupees R divided by 100. If interest for rupees 100 is R, then for 1 is R divided by 100. It is unitary method. But interest on rupees 1 is that, but interest on rupees P is equal to, and interest for T years is, it must be more. So you should multiply P and T to R. So P into T into R divided by 100. So it is the interest of rupees P for time T years. This is your interest. So you can say it is your simple interest. This is the derivation of simple interest. Now example 1, it is related to simple interest. So a sum of rupees 2500 is lent at the rate of 6% per annum for 2 years find a simple interest. So solution: principal rupees 2500, rate 6%, time 2 years, simple interest is how much? Then we have SI is equal to PTR by 100. So P is equal to 2500, time is 2, rate is 6. Then you can cancel these two zeros. Then 25 twos are 50 into 6, 300 rupees. It is your simple interest. Now I want to start compound interest. Sums are said to be lean in compound interest when the interest at the end of each period of time is added to the principal and amount at the end of each period of time is taken as the principal for the next period. I want to clarify it. If you borrow rupees 100 for first year, for 1 year, your time is 1 year, your principal is rupees 100 and rate suppose it is 10%. After 1 year, you should pay rupees 10 as your simple interest. Then after completion of 1 year, you should pay rupees 10 extra. You should pay rupees 100 and another rupees 10, that is 110 total sum you should pay after 1 year, rupees 110. But if you want to deposit that 110 in that bank or in a person, then for next year that 110 is your principal. 110 is your principal. Then for next year, time is 1 year, rate is again 10%. For second year, your simple interest is 11 rupees 11, because 110 into time 1 year, rate 10% divided by 100, then 11 is your simple interest for second year. Now simple interest of first year is 10, simple interest of second year is 11. If you add these two simple interest, 10 plus 11 is 21. Your total interest is 21 rupees. So this is your compound interest. If you add interest of first year, interest of second year, then you will get it is compound interest. But don't forget, your simple interest for first year is principal of first beginning, but your principal of second year is amount of first year. Your principal of second year is amount of first year. If you are confused, you should listen repeatedly. Okay, this is the main concept of compound interest. I want to give you this example. Thus, in the compound interest, interest due to the end of each period is not paid by the borrower, but is retained by him as further loan. Now, compound interest, there are generally two types. One is yearly, another is half yearly, and another also is there. You can add one more. It is there are three types. So another also quarterly. Then you can divide it into three parts. One yearly, another half yearly, another quarterly. So suppose P is principal, T is time, R is rate of interest per year, CI is compound interest at the end of 2 years. Now you can take a formula CI is equal to P times 1 plus R by 100 power T minus 1. So it is your compound interest for yearly system. But if you want to find out compound amount, it will be CI plus principal. Principal plus CI. You will get P times 1 plus R by 100 power T. We'll discuss in another section. Now we have this one, so I will discuss this term half yearly in another class also. So I want to uh, visualize only this formula: ci is equal to p times 1 plus r by 200 power 2t minus 1 half yearly. And similarly, if the compound interest is payable half yearly, then the interest rate obtained is in this period will be r by 2%, and time period is 2.5 years, that is 2t for 2 years. Then ca after ts is equal to p type this one. Ci is equal to this one. We'll discuss this in another section. Note, if interest is paid quarterly, then ca is equal to p times 1 plus r divided by 440. If the rate of interest for every time period is different, that is r%, r1% for t1, r2% for t2, then amount a can be calculated as this one. If there are 3r, that is r1, r2, r3, you can use this like this formula: c is equal to p times 1 plus r1 by 100, p times 1 plus r2 by 100, 1 plus r3 by 100. For first year, this is principal, and you can use this formula. But for second year, this whole term is your principal. Like this way, you can add your formula. Now I want to give you an example. This example is Srijana deposited rupees 4,500 at the rate of 8% per annum for 3 years. Find the compound amount and compound interest. It is very simple question. Here principal P is equal to rupees 45,000, time T is equal to 3 years, R rate is equal to 8%, compound amount and compound interest. We need to find out this one. Okay, we have formula: compound amount is equal to P times 1 plus R divided by 100 power T, and it is 4,500. Principal 1 plus r is 8 divided by 100 power 3. Now it is 1 plus 8 divided by 100 is 108 divided by 100. It is 1.08 power 3. Then after 4,500 into 1.259712, then multiplies these two, you will get rupees 56,687.04. After this, we need to find out compound. We found here it is compound amount. Then after compound interest is ca minus principal. Ca is 56,687.04 minus principal is 45,000. Then rupees 11,687.04 is your compound interest. So this is a simple concept of your compound interest and simple interest. I want to connect it by using a video, the derivation of compound interest and uh, connection of simple interest and uh, connection of simple interest and um, compound interest. So I want to connect it by another video.
Using tables, but the procedure was very long. So in this video, we will figure out a formula to calculate compound interest. Let us quickly derive the formula. Let P be the initial principal and let R be the rate of interest per annum. We will derive a formula for the amount at the end of n years. First, let's just look at annual compounding. We make columns of years, principal, interest, and amount. For the first year, the principal will be P. So the interest will be PTR divided by 100. That is P multiplied by 1 multiplied by R divided by 100. P is the principal at the start of the year. 1 is the time period in years, and R is the rate per annum. This is also equal to PR divided by 100. The amount for the first year will be this plus this. P is common to both the terms. We get the amount as P multiplied by 1 plus R by 100. This is the amount we will get if we withdraw the money after a year. Since we're trying to find the compound interest, this will be our principal for the second year. In the second row, we write P multiplied by 1 plus R by 100 as the principal. So the interest for the second year will be this multiplied by 1 multiplied by R divided by 100. It is the same formula we used in the row above. Just that instead of P, we use this as our principal, which equals P multiplied by 1 plus R by 100, the whole square. Look at the trend. First year, it is just 1 plus R by 100. In the second year, it is 1 plus R by 100, the whole square. P remains common. Let us move on to the third year. This becomes the principal for the third year. We use the same formula for the interest. The interest will be this multiplied by 1 multiplied by R by 100. This can be simplified as P multiplied by 1 plus R by 100, the whole square, multiplied by R by 100. We add these two terms to get the amount. P multiplied by 1 plus R by 100, the whole square, is common to both the terms. So we get the amount as the common term multiplied by 1 plus R by 100. And we get the amount at the end of the third year as P multiplied by 1 plus R by 100, the whole cubed. So for the 2-time periods, this is squared, and for the 3-time periods, this is cubed. The formula can be generalized as the amount received will be P multiplied by 1 plus rate per annum by 100 raised to number of time periods. Instead of making a table by forming 4 columns, we will get the amount due in just one line using one formula. Notice that we get the total amount in the formula and not just the interest. We know that the total amount equals the principal plus the interest accrued. So the interest is calculated as total amount minus the principal. And remember, this P is the initial principal. So if it is compounded annually, the rate per annum will be R and the number of time periods will be N. The amount received will be P multiplied by 1 plus R by 100 raised to N. What if it is compounded half yearly or quarterly? Do we have to derive another formula? No, we don't. We need to just modify this one. If compounded half yearly, then what will happen to the number of time periods? As there are 2 half years in a year, they will double. And the rate of interest for each period will be half that of the rate for a year. So the amount will be P multiplied by 1 plus R by 2 divided by 100, the whole raised to 2n. How did we get this? The rate is divided by 2 since we are calculating interest for 1 half year at a time, and the time periods are doubled as each year has 2 half years. Similarly, if interest is compounded quarterly, the total amount will be P multiplied by 1 plus R by 4 divided by 100 raised to 4n. We get this formula as there are 4 quarters in a year.
Okay, students, in this video, time is represented as n. Don't be confused. And I hope this video will clear you the derivation of your compound interest. Don't be confusion. This is very simple for you, and I want to show you another video which helps you to find out the difference between uh, two terms, compound interest and simple interest. So wait for a minute. uh,
As interest on interest. In order to properly understand how compound interest works, we must first understand
In
what
the
simple
previous video,
interest
we
is.
found the total amount
Simple
due
interest is
after 3
interest that is
years
paid
for this
only on
case.
the
Now we have to find the compound interest on 10,000 rupees for 3 years at a rate of 5%.
initial principal
Find
of
the
a loan or
total amount
deposit
due
and not
after
on
3
any
years.
interest that is earned.
In one of our videos, we understood the need for compound interest. Let us form a